Okay, so this is our signal. So this is the signal that we have applied as input to this circuit. So the circuit consists of a resistor and a diode in series. However, the diode appears to be in the upward direction, that is oriented in upward direction. So probably you have already mentioned, and if I haven't mentioned it, um, so the diode orientation could be in two directions. Either it could be in the clockwise direction, like this one, with respect to the position of the input signal. So that means if you keep our input signal to our left, and from there, if you notice the orientation of the diode, in that case, it looks like the diode is oriented in CW direction, or it could be oriented in the opposite direction, it's anti-clockwise. That means again, if you consider the our input signal to our left, it's anti-clockwise. So there could be two possible orientation. So in that case, D1 is anti-clockwise direction. Okay? So D1 হচ্ছে আমাদের anti-clockwise direction. And then we said that we're going to follow the steps. The steps were, in step 1, determine transition state voltage. So that means the value where it means the value of, so the transition state voltage means the value of VI, the value of VI. So VI value which is fluctuating between VM to minus VM. এই যে ভিএম থেকে মাইনাস ভি এর মধ্যে ফ্লাকচুয়েশন, ভি এর কোন ভ্যালুতে আসলে ভি এর কোন ভ্যালুতে we find a situation where the voltage across the diode is equal to 0.7, but the current through the diode is 0. So like this. So you can replace the diode with a DC voltage source, but the current through the diode is 0. So that we already learned about transition state voltage. So our first step would be to determine the transition state voltage. So in order to determine the transition state voltage, what we are going to do, we are going to replace the diode, okay, with a DC voltage source of 0.7. So we redraw the circuit. Zero point. এইটাই সমস্যা হচ্ছে, ক্র্যাশ করে। the first thing we did, replace it with a and the current 0. Okay, so that means right now the circuit, the diode in the circuit is going through a transition, which means it is going from on to off state or off to on state. So let's find out at what value of Vi. We said that Vi is fluctuating from Vm to minus Vm. And in that, we need to find out just the value at which, let's say at that particular level, at value Vi, we have our TSV. So for that, let's assume the Vi is positive. Just assume it. And let's assume the current is flowing in this direction. So if the current is flowing in this direction, the voltage drop across the resistor will be this. And the polarity would be this. Now if I apply KVL, we get plus Vi minus IDR plus 0.7 equals to 0. Now we already know ID is equal to 0. So that gives us Vi is equal to minus 0.7 volt. So which means when the input signal is fluctuating between Vm to minus Vm, when the input signal reaches minus 0.7, at that instant, we're going to have transition. So our next step would be step 2, draw TSV line on input signal. So let's draw it. So in order to draw it, what I'm going to do, yeah. So let's say this is our transition state line, to make it dotted. That is a transition state line. So we draw the line. So what is that line? What does that line indicate? So this is the line where value of Vi is minus 0.7 volt. So Vi is equal to minus 0.7 volt, this line. Now how is this line significant? So this line gives us the boundary between the conduction state of the diode. So we know that diode has two conduction states. Either it could be on or off. So this line tells us, sharply divides the region for which the diode is on and for which the region for which diode is off. Okay. So that means, let's say we have let's say we have a, you have a plot, okay? And in that plot it is empty, you want to grow some plant. So let's say at some region you want to plant tomato, another region you want to plant potato, and your brother is doing tomato, you are doing potato. So we want to find a sharp distinction. So divide the land this way. So here tomato, here potato. Now, how would I know that whether you're going to tomato here or potato or tomato here? So that's why we're going to find out through this orientation of the diode. It was said that if the orientation of the diodes is such that if the diode appears to be in clockwise direction like this, considering that your signal source is to a left, the clockwise direction, in that case, if you have the transition state voltage line for any value of the signal above the transition state voltage line, the diode will be on, above on, and for any value of the signal below the transition state line, the diode will be off. On the other hand, if the orientation of the diode is such that it is in opposite, it is in anti-clockwise direction like this. Again, considering that your signal source is to your left, so it is anti-clockwise direction. Anti-clockwise direction. In that case, again, if we determine the transition state voltage, okay, so TSV, like this one. So let's say Vi is equal to minus 0.7. So that gives if you have, and then it cuts the signal. So it cuts the signal, something like that. Okay. So in that case, for all the value of the signal above the transition state voltage line, the diode will be what? On. And below it will be off. Okay. So that's what the transition state is. It gives us the boundary. Now I know that for which value of the signal the diode is on, and for what value of the signal diode is off. Okay. So that part is done. Now I know the transition state voltage line. I'm safe now. So what is our next step? So once we obtain the transition state line, so now we know. So আপনারা বলেন উপরে অন না নিচে অন, কোথায় অন কোথায় অফ?
আর উপরে হইতেছে রেড লাইনের উপরে অন থাকবে এবং নিচে হইতেছে অফ থাকবে।
Let's use a fancy way. So for all the value of the signal above the transition state line, it is off. নিচে on. তাহলে আমি কি জেনে গেলাম? I know the range of voltage for which the diode is on. So that means I can say VI greater than equal to minus 0.7, less than equal to VM. So this is the range of diode is off. On the other hand, I can write VI, okay, greater than equal to minus VM but less than minus 0.7, that is on. So this is the range. This is a off, it's on range. Okay. Also, it can be written as this way as well. Vi greater than equal to minus 0.7 of Vi less than minus 0.7 on. Now that we do in terms of voltage wise. I can do the same thing in time wise. How can you do that? So for that, you see the transition state line is going to make intersection here, here. Okay. So if I draw a vertical line, like this one, one vertical line here, another one here, sorry, here. I don't need it anymore. You see, this vertical line is intersecting the time axis. So the point it is intersecting the time axis, let's call it T1. Okay, so the point it is intersecting we call it T1. T1. And the point where it's intersecting, that this instant call it T2. So which means, so these are the values of the signal. These are the values of the signal which is above that dotted line or above the transition state line. And that happens see, so this is the interval from 0 to T1. This is the interval. You will find that all the value of the input signal is above that the transition state voltage line. Now we already know if it is above transition state voltage line, in that case it is off. Similarly, okay, from T1 to T2, if you consider all the points, okay, take any points on the signal, all the points or any points, you see all the value of the input signal is below that transition state voltage line. So in that case, we know that if it's Vi less than minus 0.7, it's on. Again, if I do this, okay, this interval, so it's too small. You look at here. So this interval, again, this interval, notice if you pick any point on this signal, so they again what? They are just above the transition state line. So again, this for this part, that is off. So we know time wise as well, when the diode is off, when the diode is on, again when the diode is off. I have the clear picture about the conduction state of the diode inside the circuit. So now that I obtained that, so our next part would be draw the input output relationship. So the input relationship. That's what we're supposed to do. And we have to do it. That means V naught Vi relationship. And we have to do it for two conditions. Once the diode is on, when the diode is off, and then when the diode is on. So let's do it for when the diode is off. So fortunately, you can use this circuit when the diode is off. So when the diode is off, we can replace the diode with open circuit. And we know the current that will be flowing is ID equals to 0 since it is open circuit. So let's say the voltage across the open circuit is V naught. Okay, the terminal voltage is V naught. And let's assume the V naught is positive. Let's also assume the Vi is also positive. Just assume. If I apply KVL, so then you can easily can find the relationship V naught and Vi. How is that? If you apply KVL, so you get plus Vi minus IDR minus V naught equals to 0. Now we know that ID is equal to 0. So that gives us V naught is equal to Vi. So this is the input output relationship when the diode is off. When the diode is off, that diode is off in the time interval when t is greater than 0, less than t1. So E interval diode is off. Again, above A interval diode is off between T2 to capital 2. And when T is greater than T2, less than T, A interval diode is off. So আমি the on off assumption পেয়ে গেলাম, off season off position output input relationship পেয়ে গেলাম. So next thing would be the input output relationship when the diode is on. Now IOD is when the diode is on. When the diode is on, we can redraw the circuit for let's redraw the circuit. Okay. Redraw the circuit. So in that case, since the diode is on, we can replace the diode with 0.7. So let's use this one. So what is the V naught then? Can anyone say what is V naught? Output voltage কত?
Sir, VI minus II.
হ্যাঁ,
VI minus II.
VI minus IR. Yeah, that is one way. So our মনে আছে DC circuit analysis আমরা বলেছিলাম, if you want to determine any terminal voltage, what is the rule? We are going to apply a KVL starting from ground all the way to the point, passing through all the element. So that means if I consider this ground, I go VI, I will pass through VI, I will pass through R, and then I'll go reach V naught. Yes, you can find it. V naught is equal to VI minus IR. That's one thing. Another way, short is there? Can't you see another shortcut way?
এই যে মানে 0.7 ভোল্টেজ এটা আরেক টার্মিনাল
Point না, minus point. So আমি যদি এখান থেকে কেবল করি starting from plus minus. So if I start my cable from here, then goes minus 0.7. এটাতে আমি assume করছি plus minus V naught is equal to 0. So that gives us V naught is equal to minus 0.7. So which means I can straight away find out the input output relationship. Okay, so then if it is the case, what will be our output? Okay, so in order to determine the output, যেটা করব, copy and paste. Okay, and let there be no overlap, no problem. So তাহলে দেখি এটা আমার যে আউটপুট রিলেশনশিপ। প্রথমটা দেখি, প্রথম অংশটা দেখি। So when the input out, when the diode was off, we found out what? V naught is equal to VI when the diode was off. And when the diode is off, এখান থেকে এখানে অফ, আবার এখান থেকে এখানে অফ। So এখন V naught is equal to VI মানে কি? V naught is equal to VI means output is going to take the same shape as input. Or you can simply copy and paste. So let me give you an example of copy and paste. So let's say this is a figure and which is dancing. So if you want to copy and paste, what are you going to do? We're going to simply no, it's not taking. আমি এখানে ড্র করি। So let's say, okay, let me check. Okay, so let's say it copy. So if I copy this and paste this, you see shape of this one, shape of this thing which has the figure and on exactly the same. তার মানে হচ্ছে V naught is equal to VI, তাহলে আপনি বলছেন দুটো আইডেন্টিক্যাল না। এটাকে যদি বলি V naught, if I say this is V naught, তাহলে V naught আর VI এর মধ্যে, আর এটা যদি VI, তাহলে V naught আর VI এর মধ্যে রিলেশনশিপ কি? V naught is equal to VI. It's the same thing we're going to do. So when the diode is off, so you can say V naught should be exact equal to VI. তার মানে এটাকে আমি কপি করে এখানে পেস্ট করলাম। আবার কোন জায়গাটা কপি করব বলেন তো? এখান থেকে এতটুকু পর্যন্ত কপি করব। All the points will be copied and then paste it here. আর কোন অংশে কপি করতে হবে বলেন তো আমাকে?
T2 থেকে
এই অংশটা আমি কপি করব, কপি করে পেস্ট করব। আচ্ছা, তাহলে this off part has been copied and pasted as output. How about the output part? V naught is equal to minus 0.7. So V naught, when the diode is on, output voltage will be simply minus 0.7, fixed. And how can we obtain? We can obtain this way. Let's and then okay, then we draw another just so this is our, you see if the value koto minus 0.7. You see from 0 to T1 diode is off, so that's why it's copied and pasted. T1 to T2 diode is on, and for that we found minus 0.7, which is a flat line. Again from T2 to capital T, diode is off, we're going to have copy and paste. And so that is how we can solve the circuit.
স্যার
Yes.
আচ্ছা স্যার, ফার্স্টে তো আপনি স্যার অ্যান্টি ক্লকওয়াইজ স্যার এই কারেন্ট ফ্লো, সরি ক্লকওয়াইজ কারেন্ট ফ্লো নিছেন, হ্যাঁ না? আমি যদি স্যার মানে এটা তো স্যার